Hey guys, welcome back to this course. In this particular topic, we are going to be understanding the concept of data trees in Grasshopper. So you'll find this particular file named data trees under your exercise files. You can just open it up in Grasshopper, and this is what your script will look like. So as you can see, you have these many boxes that you can view in your Rhino window, and you have all of these things on. So for now, for starting to understand data trees, firstly I'll turn everything else off in the Grasshopper window, and let's start from scratch. Let's start from the beginning and let's understand what this concept of data trees is. So I have actually created these four boxes and inputted them inside this BREP component, which is essentially located right here. And I have then used the deconstruct BREP component. We have seen that the deconstruct BREP component has this ability to break down a BREP into its constituent parts, which is basically faces, edges and vertices. So if I break down these boxes, you can see that it's broken down into faces, edges and vertices. Now in order to understand data trees, let's just start with the faces. Let's understand how the data of these many faces are organized inside these particular components. So in order to understand that, what I have done over here is I have taken the list item component, which is included right here. You can find list item right here, and I have made two copies of the list item component. In the first one, you can see there's a small sign, and on the other one you can see there's no sign. So I'll be explaining what that sign means. And you can also see that the wires are different. You can see these wires are dashed, and these, this particular wire isn't dashed, it's completely plain. And you can also see that this wire is also plain, this wire isn't dashed. So there are basically two types of wires. So let's understand this first component first. So basically I have used the list item component and attached it to faces. So I am wanting to extract a particular face from all of these boxes. So if I turn this on, you see that if I click on this, what has happened is I am able to extract four faces of four of these boxes at the same time. Now as we know that the way a list item works is you basically have to insert the index, and what list item does is it selects that particular index, that particular item in that index from your list. So the list over here contains the faces of these four boxes, exploded faces, and the index basically is 0. So in the 0th index, it selects 4 faces instead of 1. Now why is that? So if I change it to 1, then it selects these faces. If I change it to 2, it selects these faces. If I change it to 3, it selects these faces. Now that's really a thing that you should actually look into, that why is selecting one single item inside a list selecting 4 separate items in this list of faces. So let's explore that. Now the first thing you might have also noticed that the wire is dashed. Now in order to understand data trees, you need to understand what options you have in data trees. So if I right click on any input or any output, let's right click on this output over here which says faces. So if you right click on this, it gives you these options: reverse, flatten, graft and simplify. And we have already seen reparameterize in the previous topic. Reverse, what reverse does is it reverses the order of all the lists. That's pretty simple to understand. What we really need to look into is flatten, graft and simplify. So as you can see over here, I have attached a panel to this output. Let's go ahead and attach a panel to this output and understand, and let's take a look at the tree structure first. So if you double click and type panel, bring in this panel right here, attach faces to panel. Let's understand how this data is organized. So I'll just make it a little bit big so you can understand it. As you can see that you don't have just one single list inside this output. You have multiple lists, and those lists can be determined as 00, 01, 02 and 03. Now you might be wondering why 4 lists? 4 lists because we have 4 boxes. So every box has been split up into 6 surfaces, because if I split up this one box, so if I split up a cuboid, right, it splits up into 6 different surfaces. So every box has 6 surfaces. 6 means 0 to 5. As I had explained earlier, anything that you do in Grasshopper which consists of a list, it always starts from 0 and ends at n minus 1. So if n is 100, it will always end at 0 to 99. If your n is 98, it will always end at 97, which means 0 to 97. If I have a list of 50 items, then my starting position will be 0 and ending will be 49. That's how Grasshopper works. So in this case, I have 6 faces in a box. So that's why I have 0, 1, 2, 3, 4, 5. Starts at 0, ends at 5, which means 6 faces. So I have 1, 2, 3, 4, 5, and 6. 6 faces. 6 faces of each box have been organized as 4 different lists. So you have basically 4 boxes, so 4 lists and 6 faces in each box. So you have the first list as 0, 0. Second list as 0, 1, third list as 0, 2, and fourth list as 0, 3. So you have these 4 lists. So inside each list you have 6 faces. That's how this data has been organized. And you can also see there's an extra 0 before the syntax of every list. So this particular number signifies the name of the list, which in this case is 0, this case is 1, you scroll down, this case it's 2, this case it's 3. And there's always a 0 added before it. Now that's a very genuine and a very old habit of Grasshopper. It will always add 0 before the name of a list. If you want to remove those zeros, there's a technique to it. I'll actually tell you after we have gone through flatten and graft. But let's understand this particular concept first. So you have all of these lists, you have 4 lists because the data is grafted. Now you need to understand what grafting is. If I right click on faces, you see you have 3 options. You have reverse, flatten, and graft. If I graft something, the wire will always be like this. This means that the data inside my list is grafted. Grafting also has the symbol of this, an upward arrow. So if you see an upward arrow somewhere, or if you see the wire is like this, it means that the data is already grafted. Or if you see an upward arrow, that means the data has been grafted manually. So in this case, it's already grafted. I don't have to graft it individually. So that's why its data structure is like this. So if you have multiple lists inside a single list, that means the data inside your list is grafted, which means over here I have multiple items inside one single list. So this is one whole list, the main list, and I have 4 separate lists. I have list 0, list 1, list 2, and list 3. 4 separate lists. Each of those lists have 6 items inside each list. So that is a grafted data structure.